Today we're going to continue our study of numerical expressions by converting numerical expressions into unit form as a mental strategy for multi-digit multiplication. We've used unit form before when we were working with adding, subtracting, multiplying, and dividing decimals. We're also going to use a lot of our visual models that we learned in Lesson 3, which were those tape diagrams. So take a moment. Write your learning target in your math journal. Convert numerical expressions into unit form as a mental strategy for multi-digit multiplication. Our problem of the day that we're going to take a look at today is the Layson School turns 101 years old in June. In order to celebrate, they ask each of the 23 classes to collect 101 items and make a collage. How many total items will be in the collage? Use mental math to solve and explain your thinking. So mental math, we're not going to write it down. We can use in our head a tape diagram to think about how they would multiply, because we're going to multiply this. How many total items? So we have 23 classes, and each of those 23 classes are going to collect 101 items. And we don't want to add 101 23 times. So we're going to use the math operation of multiplication to solve how many total items the school is going to collect. And we'll come back to this problem at the end of our video. So let's look at this. So it's kind of hard to see at the top of the screen, but you have 8 times 29. We're going to try and solve this in mental math using different ways. So we have 29 as the unit. We would add 29 8 times. Well, 8 times adding something would take a little while, so instead we're going to do 8 groups of 29. We'd multiply 8 times 29. What if 8 was the unit? In that case, if 8 is the unit, we're going to make 8 29 times, adding 8 29 times, or, in this case, 29 groups of 8. Now let's think about how the problem shown at the bottom, 8 times 30, could help us solve 8 times 29, our problem at the top. Well, we could multiply just the 8 and the 3 in our heads. If we multiplied 8 times 3, and simply 8 times 3 equals 24. We learned our powers of 10 if we have a 0, so 8 times 30 is going to be 240. But our problem is 8 times 29. So what could I take away from this 240 to help me solve 8 times 29? If you said you would take away one of the 8s, you were correct. So you do 240. You take away one of the 8s because we only need 29 8s and not the 30. 240 minus 8 will give you 232. Here's another way to represent that using a tape diagram. We have 30 8s in our top visual here. That's 30 8s, whole numbers. And at the bottom we have the 29 8s, and it's just 1/8 short, 1/8 less than we had before. So the expression would be 30 times 8 minus 1 times 8. And the 1 times 8 is our 8. 30 times 8 we said was 240. Our 1 times 8 gives us 8. 240. I have a plus, it should be a minus there. 240 minus 8 gives us 232. Here's our next practice problem, and this one you're able to see at the top of the screen, 49 times 20. So 49 is the unit. How many times are we going to add 49? Well, we'd add 49 20 times. Or we would say 49 groups of 20. What if we have 20 as the unit? We would add 20 how many times? 49 times. We would say 20 groups of 49. If we wanted to write that as an expression, we can help ourselves by writing which is easier to work with, 49 20s or 20 49s. If you had 49 20s, you would look something like this in a tape diagram. 49 20s, that's our unit. All these 20s all the way down, there'll be 49 of them. Or we could say 20 49s. We have a rough tape diagram with 49 as the unit. And we would have 20 of those. 20 49s. So which one's better for you? Well, here we have 20 as the unit, and they have used 40, 50, 29s, 50 groups of 20 to help us with mental math. So 50 groups of 20, which would be 50 times 20, 5 times 2, whoops, 5 times 2 is going to give us our 10. And then we're going to add 2 zeros to that. But that's not what we're looking at. We want 49 of them. So we're going to cross out that last one. We're going to do 50 times 20 minus 1 times 20. Just like we took away the 8 before, it would take away a 20 here. So 50 times 20, we said was 1,000. Minus 1 times 20, which was 20. You get 980. And if we clear our screen here, we'll be able to see our hint. Here's our 40 times 20. We can break it down as 40 20s and 9 20s. That would work as well. So 40 times 20 and 9 times 20. Remember, putting it in unit form. 40 10s and 9 1s. 4 times 2 is 8. Add your 2 zeros. 800 plus 9 times 20. 9 times 2 is 18 and be 180 with our 0. Again, 980. But 20 times 51. We can use 51 as the unit. Add 51, a total of 20 times. That would be 20 groups of 51. What about 20 as the unit? We're always working with what works best for us. 20 as the unit would mean to add 20 51 times, or we would say 51 groups of 20. I'm going to decide what works best for us. Is it easier to work with the 51 20s or the 20 51s? Here we're going to work with our tape diagram to draw an expression that's going to be equivalent to helping us solve 20 times 51 mentally. I'm going to use 20 as my units. And if I did 50 20s, then to solve this problem, we just need one more 20, right? And make it 51 20s. Just add one more 20 to the end. Now it asks us to find its value. So if I did on the side 50 times 20, I have 5 times 2 is 10. I have 2 zeros. I have 1,000. Well, in order to find 51 20s, I would take the 1,000 and add what to it? Add one additional 20. I'll have 1,020 is my product for 51 times 20. 101 is the unit. 101 12 times. It's hard to see up here. 101 times 12. You'll have 12 groups of 101. Or we can add 12 101 times. That's kind of hard. 101 groups of 12. For multiplication makes it really easy because multiplication we're actually going to be doing repeated addition. So you can decide the unit, 101 12s or 12 101s, and what works best for you and find its value. For me, I'm going to do 100 12s, and then what would I have to do to find 101 12s? Very good. You'll have to add another 12, and you'll have 101 12s. So 100 times 12. 12 times 1 is 12 plus 2 zeros. 101 times 12 is our 1200 plus another 12, so 1212. 12 is the unit. This is 12 times 98. Add 12 98 times. Woo! So you have 98 groups of 12. Or we can have 98 12 times, and we would have 12 groups of 98. Again, like in the previous problems, you're going to decide what works best for you. You're going to draw the tape diagram and write the expression that helps you solve this mentally. So for me, I'm going to do the 98 groups of 12. I start with 100 groups of 12. And then I'm going to knock 2 off of that. And that'll be my 98 total. So 100 groups of 12, 100 times 12, again, 12 times 1, plus my 2 zeros. 98 times 12 is going to be 24 less. 12 plus 12 is 24. So I would take 1,200. Now I subtract 24 from it. 10, 9, 1. 10 minus 4 is 6. 9 minus 8. 9 minus 2 is 8. Let's get ahead of myself. 1,186. This is our equivalent expression that helps us solve that problem. Back to our problem of the day. Layson School turns 101 years old in June. In order to celebrate, they asked each of the 23 classes to collect 101 items. Well, 101 is kind of hard, so we'll do 100 times the 23 classes. And then in order to solve the 101, we'll add another 23 to it. So each of the classes is accepting 101 items. Let's start with 100 times 23. I've got 23 times 1 is 23, plus my 2 zeros, 2,300. Remember, I've got to add this other 23. So now I have 2,300 plus 23. Get 2,323. That's 101 classes. 101 items times 23 classes. So here's a recap of what we've done today. Today we have been able to and I lost my flip chart.